Hi everybody, welcome to a new video about experimental skills. In this video I will explain you something about measurement errors or uncertainty and how we write them down according to the correct scientific notation. And in our experiment of the simple pendulum swinging back and forth, I want to know the length of this pendulum. So I'm going to measure this using my tape measure. And since it's an experiment, I'm going to write down to draw a setup. So over here, got my ceiling, mass, and over here, got the center of gravity, and that's and I'm going to measure the position of the center of gravity with respect to the point where it's attached to the ceiling, because gravity is the driving force for moving back and forth, for moving this pendulum back and forth. So I'm going to use a tape measure, and I'm going to measure up to here. So this will be my tape measure. And I have to look from here to the center of gravity. So I'm just going to do that. So over here I got my mass, and here I got my tape measure. So since the ceiling is magnetic, I can simply stick my tape measure to the ceiling, and the length I'm measuring is 77.75. So let's write it down. The length is 77.75 centimeters. However, if I would really zoom into what I'm doing here, so like this, so this is basically how it looks like and what I have to read. And I have to read it like this, so something like this. I think over here it's 77.75. But now we come to the point where measurement errors or uncertainty exist. Well, since I don't have really good eyes, the tape measure is a bit flexible, and maybe I didn't get the angle right, and maybe we didn't get the center of gravity exactly on spot. Actually, I wouldn't be surprised if this would be 1.5 larger or smaller, this length. So this could be easily 77.90 centimeters, or it could be 77.60 as well. So I've got a length which is, according to my measurement, it's 77.75 centimeters, but it could be 0.15 centimeters larger or smaller. Okay. And since no measurement is infinitely correct, is infinitely precise, there are always measurement errors. And when you want to do experiments, you need to deal with this. And these measurement errors say something about the accuracy of your experiments and the reliability of your results. Therefore, here's a scientific convention. Scientific convention, which is used throughout all sciences and worldwide, how to write down your measurement data. So here I've got a measured value, so that would be my length, measured value or quantity. That's equal to the nominal value, so nominal value, and in between brackets there is the uncertainty or error. Uncertainty. So my nominal value in this case would be 77.75. My uncertainty would be this. So this is my nominal value and measurement error or uncertainty. Okay, there's some rules in writing this down. The first is that this uncertainty always has to be rounded to 2 digits. That's the first thing. The second thing is that the order of the uncertainty is equal to the order of the last 2 digits of the nominal value. So the last 2 digits of the nominal value. So in this case, it's actually pretty easy. These are the last 2 digits of my nominal value, and this is my uncertainty. So my length will become 77.75, and in between brackets will be 15 centimeters. And so if I would, for instance, have a mass, measure the mass of my mass of this unit at a simple pendulum, I would read, for instance, mass is 0.493. So that's the mass. I can read it from the scale, but my scale has a measurement error of 0.30 grams. So now you can already see that this measured value is actually more precise than the error. So this last 3 doesn't matter to my value. So this will become, the mass will become 0.49 and in between brackets 13 grams. So in order to represent measured values and their uncertainty graphically, you can, for instance, display values along the y-axis of a graph. So here I've got, well, it may be the y-axis of some graph, and I want to display this value, 77.75 plus or minus 1.5 millimeters. Then I'm going to write down my nominal value over here. So 77.5, so that will be here. So over here I've got my nominal value. And then I'm going to include the error bar. And it looks like this. So it may be 90 and it may be 60. And this is called the error bar. And an error bar shows between which values the nominal value should be. So where to expect your measured value. And these error bars are extremely useful when you go fitting later on to find the exact location of your fit, of the most suitable location for your fit. So there's some assignments. Please start doing assignment 1 of the reader. And well, I wish you good luck with this assignment and hope to see you in the next video about calculating the measurement value. Good luck.